Hi dear students, this is Bhusab Sonali, Assistant Professor, Department of Chemistry, Arts, Commerce and Science College, Jawahar District, Paragon. Dear friends, in the last part of the video of this solution or for the study of solution, we discussed about the ideal solution and we will also try to derive the equation for Raoults law for ideal solution. But it is observed that most of the solutions show appreciable deviation from the ideal behavior, and these solutions are called as non-ideal solution or the real solution. Here in this part of the video, we are going to talk about such non-ideal or the real solution. There are some characteristics of this non-ideal or the real solution is that they do not obey the Raoults law. It means they shows a deviation from the Raoults law. Raoults law, it is very important that we discussed in the previous part. Again, in case of a non-ideal solution or the real solution, the activity of component in the solution is not equal to its mole fraction, which is observed in ideal solution. Again, the volume of the mixing of the two liquids does not remain equal to zero. Means delta V of mixing in non-ideal solution is not equal to zero, and enthalpy of mixing is also found is not equal to zero. So delta H of the mixing is not equal to zero in case of a non-ideal solution, and it is also observed that the vapor pressure versus mole fraction curve for ideal solution shows deviation. For non-ideal solution shows deviation to greater or less extent from the theoretical straight line in case of a non-ideal solution. Hence, the real solution shows deviation from the Raoults law, and the deviation from the Raoults law may be positive or it may be negative on the basis of type and the nature of liquids that are mixed to prepare the non-ideal solution. So, which liquids are mixed to prepare the non-ideal solution based upon their type and nature, there is either positive or the negative deviation from the Raoults law. In the first case, positive deviation, if we talk about the positive deviation from the Raoults law, in case of a positive deviation from the Raoults law for non-ideal solution, it is observed that when the vapor pressure of non-ideal solution is greater than the total vapor pressure obtained by Raoults law. It's very important to discuss about the positive deviation from the Raoults law. The total vapor pressure of non-ideal solution is greater than the total vapor pressure of solution obtained by applying the Raoults law. Then the deviation observed are called as positive deviation. Then the deviation, total vapor pressure is greater than the vapor pressure obtained by Raoults law. Then the deviation observed is called as positive deviation. Again, this positive deviation observed when the attraction between the two molecules of the same type is greater than the molecules of liquid A and the other liquid. So here this is the condition. If the attraction between the similar molecule is greater than the attraction between the different types of the molecule, then this deviation is observed. And this is the diagram. Here in this case, so these are the dotted lines. This dotted indicates the variation of vapor pressure with the composition for ideal solution. Means these are according to the Raoults law for for individual components, and this is for the mixture. This is for the solution. But in case of a positive deviation, you will find that the positive deviation here in this case, this vapor pressure either for both the component or for the solution is greater than that of Raoults law, or that of vapor pressure obtained from Raoults law. And here delta H of mixing is positive and delta V of mixing means the change in volume is also positive. Therefore, the vapor pressure composition curve of both liquids, or the vapor pressure composition curve of two liquid and the solution lie above the ideal values or the ideal curves. This is very simple, And this is dotted line indicates that I already discussed, that I already told. This dotted line indicates the behavior in accordance with the Raoults law. This positive deviation depends on the several factors. The liquid pairs showing positive deviation from the Raoults law must differ in polarity of the molecule, intermolecular forces of attraction, association of either component of liquid phase, and the length of hydrocarbon chain of the molecule. The magnitude of positive deviation depends on the extent of difference between the liquids in the above characteristic, and in some cases the deviations are small, but in many cases deviations are appreciable. And there are different examples which can show the positive deviation from the Raoults law. Here, acetone plus carbon disulfide, CCl4 plus toluene, water plus methanol, CCl4 plus heptane, heptane plus ethyl alcohol. These are some deviations. Here it is not necessary. And here, in case of positive deviation, the the partial vapor pressure of component is greater than the vapor pressure of that component in pure state into its mole fraction, just according to Raoults law. And the total pressure is greater than the partial vapor pressure of A and B in solution as well as in pure state. In case of a negative deviation from the Raoults law, it is observed that the total vapor pressure of non-ideal solution is less than the total vapor pressure obtained by applying the Raoults law. And the deviation in such case observed are called as negative deviation from the Raoults law. And this negative deviation is generally observed when the attraction between the molecules of liquid A and those of liquid B is greater than the between the individual molecules of liquid A or liquid B. So here this is the simple case. If the attraction between the molecules of different type is greater than the attraction between the molecules of the same type, then this negative deviation is observed from the Raoults law. The negative deviation arises from the fact that this already, and here delta H of mixing, then that is change in enthalpy of the mixing is negative, and change in volume of the mixing is also negative. And therefore here vapor pressure composition curve of the two liquids and that of the solution are present below of the ideal solution. So these are the curve, these are the line indicating for ideal solution, and these are the for solution. These are for the ideal and these are for the non-ideal solution. So definitely these are again some examples of the solution which shows negative deviation from the Raoults law. And if P is the total pressure of the binary solution, P and PB, these are the individual vapor pressure, means the partial vapor pressures of liquid A and B in the solution. P0A and P0P, these are the vapor pressure in the pure state then of A and B respectively. And XA, XB, these are their mole fraction. Therefore, then we can come here. In case of a negative deviation, this PA is smaller than the PA0 into XA, and PB is also smaller than the PB0 into XB. And this total pressure is also smaller than the partial vapor pressure of A, and total pressure is also smaller than that of partial vapor pressure of pure component B. So these are the two types of the deviation that we observe in case of a non-ideal solution. One is the positive deviation from the Raoults law, another one is the negative deviation from the Raoults law, and also we discussed the various characteristics or the factors on which the positive deviation or the negative deviation depends. So dear friends, in this part of the video we try to discuss about the non-ideal solution and different characteristics of this non-ideal or the real solution, and we also try to compare this with the Raoults law or with the ideal solution, and we found that either there is a positive or the negative deviation is observed in case of a non-ideal solution from the Raoults law. So dear friends, in the next part of the video we will try to discuss some non-ideal solution, particularly in case of an immiscible liquid pairs. So we will resume in the next part of the video. Thank you very much.